We want to present recent research of a laboratory consisting in a telepresence robot focused on providing mental health care for COVID-19 patients, named Voodoo. The development of the robot took a four-stage approach. A first step of design was taken in order to address the requirements of the healthy. This work was done in a period of 4 weeks, thanks to the previous experience of the team in Robocup at Home competitions. A first visit to the hospital with the working prototype was carried out. During this visit, how the robot interacts with the hospital's infrastructure was analyzed. In addition, the hospital Department of Healthcare and Associated Infections analyzed the robot and defined the requirements for its future operation in the hospital. During following visits, the robot was operated by a psychointensivist and it interacted with patients. This experience was very successful, but other two requirements arose: the need for controlling the tilt angle of the camera for proper interaction with patients lying or sitting in the different positions, and the need for having microphones with noise cancellation to filter the noise generated by equipment used in the ICU. A final validation was carried out in a third visit. During this visit, the robot was inspected, and we got the final approval from both the HAI department and the ethics committee for using the robot inside the hospital. The main design requirements for the robot were simplicity, high usability, and easy operation by healthcare workers, and the possibility of being operated, handled, and transported by a single person. Moreover, the robot needed to be designed, developed, and built at a low cost, in a development time frame of just a few weeks. In addition, by considering the impossibility of having in advance neither accurate maps of the hospital where the robot would operate, nor the accurate location of the patient beds, the alternative of having autonomous operation was discarded, and it was decided to design a robot that operates in an assistive teleoperation mode, based on off-the-shelf devices. Also, open source software and the ROS framework was used in order to speed up the development. Here we can see the latest version of the robot with an updated position of the depth camera for better detection of obstacles in the hospital environment and improved audio output. This to overcome the ambient noise present in the hospital. In the two other photos, we show the proof of concept of the robot, analyzing the maneuverability around the hospital, like elevators, and long hauls to check the range. The robot was designed, built, tested, and deployed in just 8 weeks, mostly during an intensive quarantine in the city of Santiago. The three key aspects of this achievement are: 1. An interdisciplinary team composed of neurologists, psychointensivists, engineers, and designers who knew the specific needs to be filled and had a technical means to fill them. 2. The high commitment of the development team composed of students. And 3. The use of off-the-shelf devices and ROS packages which allow fast implementation of the robots. Two Voodoo's robots are used in 2 Chilean hospitals in order to regulate their use for providing mental and emotional health care to patients in the ICU. Thank you.